Okay, we're going to get started. Okay, I did the introduction before, but just a quick reminder for anyone who just came. Alicia is going to give a session now and cover some of the things you saw in Chajes, and particularly the circular factory in Honduras.
Thank you. Yeah, thank you, Chase, very much, Chance, for the introduction. And I'm very happy to be here and share a little bit of our inspiration and how we came to Circular Factory and where we are at right now on our path. So I have been working on the path of like digital fabrication and robotic construction for the last 15 years, and kind of being really interested in how can we build new geometries, new shapes that could be similar to like maybe a more efficient structures that we used to have in the past, but that since modernism we have left behind and we don't see in our built environment anymore. And that path led me to start to work with robotics, to look at other techniques and other ways of describing geometry, of using material, and of building geometries. And I think that one of the big questions that we have as we think about new cities and as we think as the evolution of the built environment is, for example, how like in the car industry, cars look different now than how they used to look in the 1900s. And they have evolved according to the technology that is used to build them and the resources that are used to build them. And differently than that, on the built environment, we don't really see that kind of difference. We really see that the buildings look very much the same, or sometimes even worse than 1900s or than a long time ago. So the main question is when we are looking at new cities, at new developments, can we build in a different way that is more efficient, that is more sustainable, and that also is more aligned to human life and to more ambitious architectural pursuits? And something for me like very interesting as we work through this is when we find that the ways that we build right now in 2025 are based on patents that are coming from the 1900s. For example, reinforcement bars for concrete, or this is also from the 1866 when this patent was filed. Or if we see at like kind of CLT, mass timber, all of what we talk about now these days about timber, also we can go to the 1920s when this was invented. So the idea on Circular Factory and of what we're pursuing is how can we, what will be the modern version of this? How will this look, and how can we make this more accessible, more customized, and more distributed? And of course, we know that AI can give us a lot of good ideas. We love generating stuff with AI. However, at the end of the day, to be part of the built environment, we do have to build all of these structures, and we have to build all of these geometries. So how do we manufacture and build these ideas that when we talk to groups, when we talk to people, that they are really fascinated by forms and shapes that they don't see normally in the built environment? And how can we make this accessible, affordable, and efficient, and also participatory for everyone involved? And those are the kind of tenets of what we have been working on. Why do we use robots, and why we have been shaping Circular Factory on robots is because they are really accessible machines. They are very cheap compared to other larger fabrication machines that are on the industry for like traditional orthogonal construction or panelized construction or mass timber. So we focus a lot on robotic arms. We know that there has been a lot of work since the early 2000 with the Grammatian Collar at the ETH and a lot of other universities and institutions really looking at robotic fabrication as an alternative. And the other thing is also that we know that the machines are very flexible. So like whatever you can hold on your hand, whatever tool you can have, robot arm can also hold on their hand. They can also use the same chainsaw, bandsaw, gripper, pencil, marker, whatever you can think of. And that's kind of, we kind of started to play with this and to see, okay, what are the different kinematics, the different solvers, the different ways that we need to program robotics, but also how can we build geometries that have a different language, but that also is reflective of the robot, of how the robot works as opposed to of how the human works. And also, how can these geometries be built in an efficient way? So this is kind of some experiments that we did at the DRL, at the AA, on a master studio I was leading with Shaje for 5 years, and where kind of really all the ornamentation is coming from the robot arm. And also, how can we mix a lot of these methods of construction with traditional methods of construction? So not making everything new, but also taking expertise from things that are very well established, that people know how to do, that people are comfortable doing, and just bringing that layer of innovation on top to be able to make it different, to make a difference. So that's kind of the things that really interest us. And something that we know is like design for manufacturing and assembly, the main precept of the industry, DFMA, came on the 1980s, when a lot of the on-site construction, a lot of the fabrication basically got moved into factories, into shops, and a lot of the built environment of what we see around us today is made of construction seen as manufacturing, which basically means that the houses, buildings are produced off-site in a remote location in factories, and are then transported to site to where they are going to be deployed. What that means on the one hand is that we have a lot of repetition, a lot of standardization, as opposed to normal housing where you kind of have your own personality or individuality, and also it also means that that is on the hands of very centralized and very few companies that can afford these very expensive machines, that can afford the larger spaces of where these machines are positioned, and also the knowledge to operate these machines. So what we are trying to do is how can we reduce the initial cost to use the machines, and also the knowledge and the learning curve to enable more people to participate in this digital space of fabrication. And also a lot of the work, especially we will see with Prospera, but with cities, is like, how can we also get engaged with the small, medium companies that kind of are like around 98% of the contracting firms on construction industry, as opposed to have it centralized on only being offices and big construction companies. So from DFMA, a concept from the 1980s, design for manufacturing and machines, we are trying to move to this new precept of what we call from design for manufacturing to design for robofacturing, DFR, which is like flexible robotic cells that can robofacture high quality products using a single arm machine, simple machines that are cheaper and more easy to use. So human, or what we call human compatible digital fabrication. So how can we move from a concept of design for manufacturing and assembly towards a concept of design for robofacturing? And some of the things is like, okay, how can we move from like these large machines, centralized, to distributed microfactories that can be placed in remote locations, that can be placed all over the world, and that are based on like machines that are more flexible and more affordable. So this is what we're trying to do. And also, how can we get closer to the tradespeople, closer to the design team, closer to the developer, closer to the investors, in a way that all of these different trades, all of these different participants are engaged together within the same digital platform, and they can have transparency and visibility towards the whole fabrication process. It's not only that you kind of receive an invoice, receive an estimation, and then you have to pay that, but how can we make this very transparent to everyone involved? And again, we use the robot for spatial scanning, milling, assembly, 3D printing. So we do have a lot of different processes embedded in our machines in the circular factory. Pick and place, 3D printing. So these are some of the tools that we also use. And of course, something that we are also starting to see now after 2 years of operation is how it can start to benefit the local economy. Because as opposed to factory-made construction, all the materials that we source are local, are from, in the case of Prospera, are from Honduras, but also all the local people, all the local trades that we are using, that we are training, that we are upskilling, are local to the community where the microfactory is based. So that is a very critical part of what we want to do. And you also, and there are also additional or periphery industries that get benefited. For example, we have a person that has a kitchen cooking for the workers. So it really kind of starts to bring construction, starts to bring benefits to a bit of a bigger ecosystem than what we expected. And that has been like something very interesting for us to see how we have now additional industries serving our factory. So something that we also are looking at and we have also very engaged with is cyber physical platforms. And we know, like I think Shaya mentioned Jane Jacobs, but like how the point of cities is to have this multiplicity of choice. So how can we engage the user, the buyer into the decisions of the design that is being fabricated. So it's not only the architect and the designer, but also people can have a choice. And we have developed a platform, for example, in this case, this is a facade in Canada that we were designing where there are multiple options, everything is differentiated, every component is based on it's a conversion from an office building into residential, so these used to be offices, now there are flats. How in your flat you can decide what is the view you have, the facade, the transparency, the different opaqueness of the panels, so you can have many decisions. Whereas you want to have more solar gains, less solar gains, but how can people actually understand this and be part of the design? So for that, we developed like a game, it's in Unreal, where what we are trying to do is give people feedback, so like as they are kind of selecting and choosing, we are getting them, well, that will take more manufacturing time, that will take more robotic time, that will have more thermal gains, that will create what is your thermal comfort, but also solar gains, what is your view? And the idea is to make a lot of these parameters accessible for a common user. So like we kind of work into how do we group these into terms that make sense, like radiation, sky view, fabrication, and people can be selecting, moving, and the same, and a little bit like when you go to a supermarket, you buy food, you can see the calories, carbs, proteins, etc. Can you see the manufacturing time, the machine time, the electricity consumption that every single decision that you make on the built environment have? And does that actually help you make decisions, or people doesn't really care at all? So that's part of the work we have been doing. Of course, on the background of the platform, we are doing all of the simulations. So we are running all the simulations of like, for example, thermal analysis. People don't see this, but also what is acceptable for construction, what is acceptable for the deformation of the curvature of the different glue laminations for the facade. So people are only allowed to pick between things that we know can be made, although they will have different costs and they will have different implications. So between what is acceptable, they can have an option to decide. And this is kind of something, ongoing research that we have been going and testing it with expert users, like designers, non-expert users, like maybe developers, people, or just like clients, right? Just people that will inhabit the building. And kind of giving them all of these options as feedback information into their decisions. And also, of course, when the whole aggregations come, this starts to be what will happen there. So yeah, maybe this is not working. And then, and all of this data is also based on fabrication. So we are also at the same time using the robots, using the fabrication system to know, okay, what is the maximum deflection, what is allowed, what is not allowed, how long the robot takes to do it. Our robots are also running on like generators, so we know the electricity consumption. So we are trying to capture as much data of every single step as possible, so that you can know exactly how much, not only machine time, but electricity consumption your decision could have on how the components are produced. And then the robots are also same machine again, so bends, then it's kind of also milling. It's also doing all of like the mitering, all of the cutting. So single machine, a lot of multiple processes embedded at the same time. So trying to reduce, trying to make them as flexible and customizable as possible for all of the different requirements that the clients might have, or the developers might have, or the people using these buildings. There's something funny. Yeah. And then this is, for example, one of the prototypes, full-scale prototype that we are building. Another thing that we are also, that we have built based on user decisions and feedback. And something that we also are using in the shop is kind of looking at machine learning as a way of like understanding material that are heterogeneous, that are not like wood, for example, like timber, that has a lot of different characteristics, a lot of different natural processes, like for example, knots, grain directions. So how can we detect all of these before we do our laminations, so we also can have the more efficient kind of use of the material? And our workers at the shop, although they don't know any of these, when they are laying out the laminations, when they are laying out the pieces, they can get visual feedback of where to place them, how to place them, to avoid any imperfections or to make the process more efficient. So this is also things that we implement. And also dynamic milling, like how can we change our speeds, our feeds, to be able to have the best results as we go. So a lot of these are the kind of inner works of the platform and the research that we are doing to incorporate on the platform before doing the circular factory. and what we kind of are offering as part of our cyber physical platform. Then and a lot of different wood also. So we also work in like how can you have different combinations of wood, especially like for example in a place like Honduras, they do have timber, which is pine, the more normal construction material, but they also have like walnut, like mahogany, like very precious woods. So can we have hybrids where we have the precious woods maybe on the outside for a water resistant, for like make them less affected by like termites and bugs and all of this, but keeping the core like lightweight. So we are also looking at a lot of these hybrid compositions to make the best use of the material available. They also have a lot of teak, a lot of like really expensive and really nice wood that we are really trying to make these compositions, so like trying to promote for all of that. And for like the expression of the construction. So again, in this case, like the laminations, if we have a lot of laminations, how can we make that very expressive in the final process? So we are trying to combine all of these into a single offering. And also, like as I mentioned before, engage with local materials, and this is something that we try to do because we know that also people, we're upskilling people. We are really working in reskilling, in building local knowledge, and also in making people proud of what they are doing. And that's something very important when we engage with communities. When we arrive to a community, we want to become part of that community. I mean, it's a new city, but we need to use the local labor. We want them to get excited and also to get better opportunities as they move on in life. So kind of, and some of the things is different to Swiss wood. Wood from Honduras is not perfect. It's not really precise, right? It has a lot of imperfections. So we really need to have a very adaptable platform to deal with all of the twists and it's crooked and all of the issues with the wood. So we kind of really try to work to that. And this is a project that we did, for example, in Rattan, just like using wood from trees that are like left over, that they don't want, that are there, and just like by scanning them, getting all of the information of the interior of the wood, of the knots, of the composition, and then trying to use that to build something. So also showing them that there should not be leftovers, right? That we can also use these pieces to build something interesting through our digital platform. So this was done with the locals, and we built like this little pavilion using like leftover logs and also finally dimensional lumber on the top. So the main aim is how can we leverage technology to create sophisticated, dynamic, and customizable processes and have technology for social innovation. So one of the first mandates, of course, Shai talked a little bit about Deja Vu. So this project by Zaha did a very ambitious project, but also one of the main things was that it was really customizable. So I think as you saw on the platform, people had tons of options that they could pick from, that they could like configure in different ways. So we had to design Circular Factory to be able to deal with all of these variations of very complex geometry and to be able to fabricate all of these decisions made by the people playing the game. And these are some of the kit-off parts or of the components that were initially. So we have different balconies, different facade elements, a lot of different louvers, the palapa roof or the curved bolted roof, the flat roof. So there was really a very interesting repertoire of pieces and of different elements that we had to be able to fabricate, and that we know that if people pick them, it shouldn't be the case that they picked something and then it's like, well, sorry, that was a bad decision, right? We need to offer a possibility. So based on this kit of parts, we designed the Circular Factory with the idea of having a factory mainly geared towards supply chains, towards localized supply chains on the island, but also towards fabrication that is complex, that is curvature, that is highly ambitious architectural formations, and that everything is designed so that you can make all of these different modules. One of the main things is that the fabrication of the main module was made out of a lightweight construction, like a stick frame construction. So we started by making that hierarchical analysis of the different components of the building. And a lot of those components, for example, were very linear, very could be done by the locals. So those ones we kind of left for the locals. We still quantify all of that to know what is the amount of material that is required. And then we kind of focus on a lot of the curvature of the most complex shapes. How can we fabricate them? Still by having a very understanding of all the different elements. And then the panels on the inside, they are fitted with like pipes for insulation, all the pipes and all of the HVAC, all of that is kind of inside each of the panels as they are fabricated. So each panel, of course, is not only using the robot, but is using a lot of different machines in the process, from like the planer, jointers, going to storage, going to glue. So really using a range of machines that we need to have on the shop, and that we also need to have the correct process to know that we can have an efficient fabrication workflow. And for the modules that are curved, they are more reliant on the robot, on the CNC, or on the different parts that have to be curved for them. So we can kind of spend quite a bit of time analyzing and getting an inventory all of these components to have a clarity into the building sequences and processes. This is the same model that you saw before, but now rationalized. Some of the things that also were important for us in the case of the circular factory is that they don't have any cranes, for example. They only have telehandlers. So the maximum weight that you can carry is 2.5 tons. So how can we ensure that there are no any panel that will be heavier than that? So a lot of this is adapting to the local resources, because it's not only building things, but it's what wood is, what machines are there, what capabilities they have. We cannot just bring large cranes or something like this. It's just impossible. So these are some of the complexities that maybe we didn't see at the beginning, but as we started to develop the project and to really engage into how we're going to fabricate this, it became really, really critical into our distribution of elements and distribution of the different loads and of the different fabrication processes. So these are all the components into elements that we know are not heavier than 2.5 tons, can be lifted and carried on site. This was the first test that we did for the fabrication of the components. So this was a test that we did in London, using the robots there at the Hook Park, and kind of before moving into Prospera and to building them. And then here again, you can see same robot, different tools, such as milling, then the bandsaw to create these corner elements, in this case, creating a cross-lamination. After this, we kind of started to also have like, how can we go from this mega factory to the micro factory that will be able to handle all of these processes? So there was a large part of research into what is the size of the module, what will be how will it come into the shop, what are the different stages that it has to go through, and how will it then actually be able to be picked up, moved away, be stored, and be assembled on site without creating like any bottlenecks anywhere in the process. And this is more or less the composition of the factory. It's a very small factory in terms of footprint, and all the production is inside there, so you can see the robot arms on the truck, 2 big robots. We also have planer, jointers, CNC machines, also a storage space, gluing space, and a painting, finishing room. So it's around 500 square meters, but not all of that is ours. We only have like 300 of those, and that's where we kind of have everything. As I mentioned before, we also have the computer vision there to be able to detect where the timber is, what are the variations, how does it work, and all of the simulation files, all of that adapts to the actual realities of the material that we find in Honduras. So what are the different timber 4x4s or timber lamps that we get there, calibration. And then the idea of the flexibility was that we can have the setup is enabled ideally to have like processing, either collaborative processing, individual processing, panel, large beams, and also small beams, and the more bulk parts of the houses. So all of this was considered on the setup. And as I mentioned before, one of the main things that we wanted to have is a very transparent workflow where we know that the design team can have access to our platform, the same as the assembly team, the fabrication team, which are our machines and workers, and also all the management where we are looking at logistics, cost, time, data analysis, and also the developers, they can have access to the platform. So all of this has been connected and integrated into a single digital platform that then kind of talks also to all the machines, and we have like tablets, for example, so these are all the different machines. We had a tablet at each station where like the workers can log in, can see, can download the code, can work, and then can feedback, whereas a part have been processed, is not processed, or has an error, they had any difficulty. So all of this we can be logging. At this stage, we have done three different projects in Circular Factory. We are still collecting data on humans, on how they use, because unfortunately there is not a lot of data of human processes. And even machine process data is very proprietary. So we are trying to collect more data to start to really understand how to make this more efficient, or actually make better, improve our time analysis and time cost projections. So all of this is connected through the platform. Everything on the shop is also connected to the same digital platform. And here, this is one of the initial videos we did. So from the original geometry, for example, the different people, the different players, they make their selection of the house. And then it comes to us. We receive this geometry from the architects. We rationalize it into those panels that we know have the correct dimensions to be transported, to be lifted, to be put on site. And then from there, we use principal component analysis. We start to analyze them. How can we fabricate them? How many, what number of different laminations you require? What is the dimensions of those different boards? Then all of this gets assembled on the shop. So this is when the workers kind of come to the shop. They will see what are the different number of panels, a number of components that they need. Then this is the CNC process, 3-axis CNC milling for the different laminations. After all of them then they get to the gluing station, where you have all of them being glued together again, assembled into a full piece. Then it goes into the robot station, where finally they get milled into their final configuration. And for every single piece, we have the same workflow, where everything gets, where it's like a step-by-step analyzed, simulated, and then uploaded into the platform. And then from there, they can download, and they can have access to the different steps. At the same time, you have all the instructions. So this is also our instruction piece, where you have that we don't have the robot cells, we have the planars, we have the jointers, we also have the gluing stations, the storage stations, the painting stations. And then here you can access all of the components, so the architects can have access to these, but we also have the developer has access, the other contractors have access to this, so they can see the different pieces, where in the process they are, when are they going to be fabricated, if they are done or they are not done. And we just want to really have this not as a black box, but have this as something that people can query and can get information back. Also, they can query them by unit, so they can also see by the different units, what is the piece, is a corner piece, is a balustrade, is a bristle the bull nose, is a flat, so they can also query them based on their position on the building. These are the different units that exist on the Beyabu project. We have this for every project that we have done also, but it's the same platform, it works on the same way. And this is, for example, if you want to also see the bill of materials, the machining time that it will take, so you can also access the identity of those pieces. Here you see, okay, where are they located on the building, on your assembly, and have access to the bill of materials, the wood pieces, adhesive, brackets, screws, dowels, as much as we can, and then what are the different steps on the fabrication that this piece will require. So it's not like a black box that suddenly you get a piece and no one knows what happened. We really want this to be, we can here see, okay, if it's in progress, whereas it's finished, whereas there was an error on the piece, and the workers on the shop, they can download the if required for CNC or for robot files. If not, they can only see and visualize what they need to do. And here, these are our estimates. Human time, machine time is very precise. Human time is not so precise. We are kind of working on collecting more data to make that a lot more precise. It's just because some people are better, some people are worse, some people are a disaster. So human time is something that we really, really need to work with, and especially when you have unskilled labor or people that are just upskilling and training, is something that we are working on improving. From estimates, these estimates are based on working with on our own work, so that means it changes a lot when people don't know what they are doing. And then here, if you go to the piece, you can see fabrication progress, for example, how much longer this piece will require. In this case, 72% is done, so maybe it already has been cut, glued, it's in storage, it's only missing the final robot process. And you can see when is that scheduled to be done, when will that be happening, and you can also see what, for example, in this case, the glue up, okay, there was an error, what happened there, right? And then it also gets dynamically rescheduled to then be done on a different time. This is the shop, actually, when the robots kind of came into Prospera. This was the initial place where we were, so it was like a dirt road. I know some of you have already been there. We had these like big robots coming. I was a bit like terrified when they were download from the truck. And this is our the robot truck, also kind of coming down from the truck. We had like it is a very kind of interesting ecosystem where you really are in a kind of area where this is really weird. But we were kind of having all of our machines delivered on site. This was 2023, like I think around May of 2023, we spent from 2020 to 2023 to kind of get to this stage. And so we also have a robot dog that we use for scanning for the site, so it also allows to get a lot of information with a LiDAR scanner of data of the site, of the composition, so it allows to rectify a lot of the level, so it's also something that we are using as, so this is the road into Prospera. And then this is the final configuration of the shop. So you can see we have the 2 robot arms there, the 2 large robot arms. And then we also have the different like CNC machines, the different stations on our configuration for the Beyabu project, but also for some of the other projects, so that the jointer, planer, table saw, the panel saw, and all of them there. And then this is like, for example, louvers that we did for tower. So same platform, but it can also dynamically adapt for like, this is the Duna tower. I don't know if you went to the Duna tower. These are the louvers for the Duna. So we built all of that inside the shop. These are the different stations when we have the people working on those louvers. And this is for the 2 years ago for the Venice Biennale 2023. We built a balcony, like a prototype of the Beyabu project. So this is the build-up of that part. This is the curve areas, all using the same digitally informed platform. And that was an exhibition right now. This is in London on an exhibition at the Zaha Hadid office. But that's kind of the balcony with the balustrade and all of the different steps of the process for one of the Beyabu units. We are also building other projects. So this is, for example, glamping cabins that we are currently doing. The first one is already finished. Again, trying to really look at these different shapes or different geometries that could be amenable for like being on nature, that could be holistically integrated into the built environment, that could also give us that sense of cocoon kind of, or like of being there. So this is a 1-bedroom unit currently. You have a kitchen, a fully en suite bathroom, and the bedroom, and then like a study, like working area. And so these ones are being deployed near the golf club, and these are like more for like maybe this kind of events when they have the cities and when they have people coming in. So this is again the working process. So these are all the interiors of the cabin, exterior with the different louvers, and again we have the robots kind of working on them. This is all transported through all the roads that you see there. So this is also a bit of a challenging process, but they are being now deployed. They are all prefabricated on panels. All the panels are coming out of the shop, going directly into the golf club near verandas, and they are being assembled on site to deploy the cabins. So it's like a bit of a combination between very digitally advanced techniques and more like the craft and the knowledge of where we are trying to upskill and to get people to do. This is one of the guys has been working for us for like 2 years now. Now he's using the robots, for example. He's a total local guy from Crawfish. So we are really trying to bring this also to an aspect of social innovation. And this is the cabin, so this is some of the views. It's unfinished, it's still missing some paint, but that's some views of the bedroom and the area and some of the sidings. So basically the main idea is to have decentralized, distributed, democratic digital fabrication through the engagement with like flexible and adaptable microfactories, software that enables a stakeholder participation where like designers, contractors, everyone can have access to see how things are being fabricated, in which stage of the process they are, and also micro-credentialing, upskilling, training local communities, and really kind of engage with them. So those are kind of the main tenets of what we're doing and what we believe is a kind of valuable thing into microfactories for construction. Yeah, thank you.
Are there any
Okay,
questions?
thank you. Any questions?
Hello.
Hello.
As a business model, like for sustainability in the long way, all the project of the circular factory, how is going? Because I understand that the demand of the services come from the real estate projects in Prospera. So that's the long way vision, that's the long way vision, and how is working until now?
No, so actually that's not the vision. The vision is to really be able to export some of them. I think that the initial conception was to kind of, for example, for the cabins, we do have clients in other islands that are interested on that. So kind of really bring digital fabrication to to the Caribbean. In terms of currently, the demand is led by Prospera projects, but we are kind of expanding into exporting them to Colombia potentially. We also have talking to people in Costa Rica and other places. So the idea is to export the finished product, but also the main thing will be eventually we want to not be in circular factory. I mean, we want the factory to transition into being operated by locals, and then we go and set up a different microfactory. So our model is not so much into creating the finished product, but into creating the microfactory, enabling it, and then being able to transition out of that and just being operated basically by locals to produce whatever they want, right? So we have louvers, we have done furniture, we have done the cabins, so kind of having this repertoire that enables them to have different capabilities. And I think ideally we kind of operate as a service model where we can come and check if something happens, but we don't are directly involved on Circular Factory 1 anymore. We are trying to get now enabled into Circular Factory 2. It's more like a microfactory as a service for the locals, and I think that is the ideal scenario where they get all the benefits from it.
Do you have a question? One question I have is I'm curious, what are the biggest roadblocks that you've found so far to the idea and the concept?
Yeah, I mean, I think that, well, of course, the bringing of the machines, all the roadblocks some are the supply chains. So supply chains, when you're in a remote location, they are complex, right? So we need to be super organized. Everything has to be very planned in advance. Even like sandpaper, you take 2 weeks to get, right? So you cannot really have a system that operates on demand or a just-in-time system. You cannot have that kind of operation. So that has been, supply chains are a problem. And also, of course, some of the situations with the government have created a bit of friction. But in general, I think, the action of upskilling and training people, because it's not so easy. It's not easy. And it's kind of getting the sophisticated technology for them to learn and to be able to use. So that has been an issue. I think we were lucky of we got all the machines and we got all of our setup when there wasn't the government was any friction. So that was really good for us. But I think that a lot of that is related to kind of operating in remote locations. So it's supply chains, machine availability, and availability of skill availability.
So when you're getting freight traffic coming in from boats, these things, do they have to clear customs in mainland Honduras first, or can you get them, order things from abroad or by plane?
Yeah, they depend from when they come from. So most of our stuff is coming from the US. So they clear customs in Ratan, and they come directly from Miami. So we bring most of the stuff from Miami. Some of the things, for example, if we are getting, all the lumber is local. So all of the lumber, all of that is coming from mainland Honduras. Some of the machines, only the CNC machines, they came from China. So those ones, they clear customs in Puerto Cortes, which is on the Pacific coast of Honduras, and then they came to Circular Factory through land and a boat at the end. So it depends where they are coming from, but most of our stuff is coming from the US.
Any other questions? Yeah.
How do you foresee the tariffs? So you mentioned that a lot of things are coming from the U.S. How do you foresee that the tariffs will impact the service, the factory?
Yes, that's something we are kind of looking into, are really closely monitoring. We don't know in terms of raw material, because I mean it's local, but only the lumber, right? Everything else we have to import. So that's something that we are monitoring closely. We don't know. So far, there's no any effect yet. As of today, we can keep manufacturing the cabins on the same costs, but it's something that definitely we don't know how long will that last. There are issues also in the case of being on the island. We cannot just suddenly bring a lot of stuff, right? Because we are in a very tropical climate, so things just not get deteriorated. Something that we are getting with all of the onshoring of manufacturing is that a lot of people that from the U.S., for example, we have received a lot of talent calls recently. People that want to move out of the U.S. but want to fabricate near site or like in Honduras. So we have a lot of applications now of people that want to come from Boston mainly. They want to come run to Honduras to work with us. So that has been a positive impact, I guess, that we get people trying to escape. But also, we also get people that are looking, we are talking to like panel manufacturers in Pittsburgh. They are looking at if they can import from Honduras as opposed to from wherever they are doing now, which might be China or other places which have worse tariffs. So I think that it's an interesting situation right now because some people are also looking at, can we manufacture in Prospera and then bring it over, and will that be better than bringing from other places? So we are, it's all new, but we are really, we have received calls in kind of all directions. So we are looking at expanding maybe into some of these panels that then could go to Pittsburgh for like some of the construction industry there, so I think it's an interesting moment that we are really just looking closely at how it develops.
Okay. All right. Thanks a lot, everyone, for coming. And just as an FYI, we're probably going to have dinner around 6 p.m. at Camino. If anyone has further questions, you can join us. And I'll get Una and Chris will come up for a couple minutes to talk about the next stages for future of Living Track. Thanks a lot, Alicia.